Hey everyone, and welcome back to this class, Deep Reinforcement Learning, Deep Learning in Python Part 7. In this lecture we are going to do a Theano warm-up. As you know, deep neural networks are easiest to write with frameworks like Theano and TensorFlow, so that you don't have to derive any of the gradients yourself. We've been slowly building up to this point. First we looked at Q-learning without any function approximation, then we looked at Q-learning with linear function approximation and gradient descent, using scikit-learn, and then we looked at the same method but without using scikit-learn, instead of writing the model from scratch in NumPy, and now we are going to re-implement the same thing in Theano. This is designed to remind you of all the important parts of a Theano neural network, creating graph inputs, defining shared variables, which are parameters that can be updated, creating the cost function, defining the updates, and compiling functions to do training and prediction. If you don't want to try to code this yourself, although I highly recommend you do, since it's only a few lines, the relevant file in the course repo is Theano Warmup.py in the subfolder cardpole. So the first thing you'll notice is that this file is pretty small. All we need to do is build an SGD regressor to overwrite the one from the other Q-learning script. At the top we're importing NumPy and Theano, and also Q-learning, which is the script we just looked at. Next we have the SGD regressor class. Now most of the work is in the constructor. At the top we're printing out Hello Theano so that you can confirm that this is the SGD regressor that's being used when you run the script. Next we initialize W as usual and place it in a Theano shared. Then we create our inputs and targets X and Y. As usual, X is 2-dimensional, Y is 1-dimensional. Next, we calculate our prediction y hat, which is the multiplication of x and w. Then we calculate the squared error, which is the cost. We get the gradient, and we define the gradient descent update. Then we compile two functions, one for training and one for prediction. In partial fit, we simply call the train op, and in predict, we call the predict op. In the main section, all we do is replace Q-learning's SGD regressor with the one we just made, and then we call its main function. Let's run this and see what we get.